Okay, here we have a breadboard. Nice thing about a breadboard is it allows you to build electronic circuits without having to solder. And you can use it over and over and over again. Now with this breadboard kit comes several things. Here's a bunch of jumpers, kind of stiff jumpers that keep a close profile to the breadboard, which is good once you got your circuit kind of developed. I've got a bunch of flexible jumpers like these, which we'll use right away. These are handy, but if you have too complicated a circuit, boy, these can be quite the spaghetti mess. So sometimes it's better to use these. But we have these. If you wanted to connect two different breadboards, you've got these headers that come with it that you can slide right in there and then use this ribbon to connect to the headers and then connect it to another breadboard if you had a really complicated circuit, which you may do sometime. The way a breadboard works is it has a whole bunch of connections, some of which are connected to each other, some of which are not. On the sides, you have the power rails. This is a plus power rail and a minus power rail. Here's another plus power rail and minus power rail, so you can have two different power supplies if you need to. And these are all connected all the way down. So you put your plus in one side, and that's what I'm going to do here. I have a little power jumper that just uses a 5-volt DC. You can use a brick. Right now I'm just using this battery pack that kind of serves as a brick, and I'm going to connect this plus side, the red to the plus side on this side. I'm going to connect the black to the negative side on this side, and so now all of this is negative, all of this is positive. So anywhere I want to tap into the positive side, I can just use one of these. Negative side, I can use one of these. And for right now, this negative's not used and this positive's not used. I just do them this way so that there's less chance of things touching together and shorting out. Now your kit comes with a whole bunch of stuff. It comes with a lot of LEDs, different color LEDs here. It comes with some push-button switches, an assortment of push-button switches, quite a few of those. It comes with resistors, and these resistors, this is just bunches and bunches of resistors. You have like 100K, that would be 100,000 ohms. Resistance is measured in ohms, all the way down to 10K, or just a 10 ohm resistor. And that's what I have here. I've pulled out a few. We've got, I pulled out 3 10 ohm resistors and 100 ohm resistor that we're going to use just to build a little simple circuit here. Now, these rows in here are all connected this way. Now they're numbered. 1, this would be 1, this is 5, so 1, 2, 3, 4, 5 on this side. Same here, 1, 2, 3, 4, 5. And then each of these has a letter, so this would be A, B, C, D, E. Now the numbers are connected together. So 1A is connected to 1B, which is connected to 1C, connected to 1D, and so on. But it's not connected over here. So 1F is not connected to 1E, but it is connected to 1J and H and so on. So all of these 5 are connected, all of these 5 are connected, but coming down here, 15 is not connected to 16, not connected to any of the others that way. So that's how it's laid out. And so if we wanted to build something, there's some other things in your kit here. You've got a few integrated circuit chips, and you have some transistors. Transistor was really the basis, the first thing they invented, the basis of electronics. And you can do lots of things with transistors. That's pretty cool. We're not going to use one today, and here you got some, looks like some microphone and speaker, looks like. You've got some capacitors. These are heavy-duty capacitors. It also comes with some lighter-duty capacitor. Or no, these are, we got some diodes. A diode will let current go one way, but won't let current go another way. You've got a couple of photocells, photoresistors, which you can use for certain things. And here's some other capacitors. These are lighter-duty capacitors than these are. And then you have like this is a potentiometer, a variable resistor. You twist the knob and it varies the amount of resistance in there. And I've pulled out a couple of diodes. Diodes are interesting because light emitting diodes, these are LEDs. They have a long prong and they have a short prong. The long prong is for goes to the positive side. The short prong goes to the negative side. If you put it in backwards, it won't light up. If you put, positive to the long side, negative to the short side, then it lights up. So I'm going to build just a real simple, very simple circuit here and leave that with you. I have a USB drive, and on that USB drive there's all kinds of information, and I know you're smart. You can probably figure most of that out, but it'll take work. It'll take patience to figure things out, but it'll be worth it if you do. And I think with this breadboard and all this stuff, if you play your cards right, this can give you an edge. It can give you a leg up in robotics, because you'll have some knowledge and some skills and some things that the average bear won't have. So this breadboard, let's build a simple switching circuit. I'm going to take a blue LED and put it right here. I've got this in, well, let me put it in row 15, and I'm putting it in row 15E and row 15F. Okay, and remember, they're not connected, so there's no worry about shorting that. I'm going to put this one also with the longer prong on the positive side. We'll put this one in row, let's say row 10, E and F. So I just got two LEDs here, and coming off of this USB is about 5 volts DC, negative to positive. Your LEDs are rated for about 3 volts. So what we want to do is put a little bit of a resistance between in series with these, so that they're not going to be pulling the entire 5 volts. Now I could just run them straight with the 5 volts, and we'd be able to get away with it. But if you had like a 9-volt battery or something stronger than that, you'd burn out your LED if you didn't have a resistor to kind of knock down that voltage. So if I take this, let's say we're going to take three 10 ohm resistors and one 100 ohm resistor. If we connect those in series, end to end, which is what we're going to do on a breadboard, then that will add the values of all of them together, so you'll have a total resistance of 130 ohms. And that's what we're going to do. We'll start with, let's see, I'll start with row, can't even see this, row 30. Row 30, I'm going to go with row 30 D to row 31 G or H, row 31 H. So it's going from here to here. And then what I'm going to do is take these guys, and I'm going to take this guy and run this guy from row 31. So it's like I'm connecting this end of each one, right? So I'm going to run it over to the next guy. So now if I connect row 30 to 31, I'll have these two in series, right? So now what I'm going to do is take this guy and run it from 31 over to 32. And then row 32, I'm going to go from also from row 32 over to row 33 on this guy. So what I've done is connected these guys in series. Whoop, that guy didn't get in there right. Let's get him in there. Connected them in series. So I start with row 30 and then go all the way to row 32, and that gives me this resistance plus this resistance plus this resistance plus this resistance, and that gives me 130 ohm resistance, which I want to put in series with these guys. So I'll connect this guy. Well, let me do it this way. I'll take my red and put my red, tap this and run my red over to row 30. So I've got my plus positive side going to row 30, going through all these guys to row 33, and then row 33, which we're still on the positive side. I'm going to take row 33 and put it over here with this blue LED. So I've got that resistance, and I could connect, if I connect this side to the negative side, then we'll have a light. So we can do this, and our light should light up, which it doesn't. Oh, I got it in the wrong pin. Got it in the wrong row. There we go. Put it in the right row, and our light is kind of going faintly. Let's see what this guy does. And there goes my red LED lighting up that way. Well, I don't want it to be on all the time, so let's wire a switch to it. So we'll put this switch in like here, okay, and that will connect. If I connect, let's see, this row with, where's my other jumper? Actually, I'll run that to the switch here. Run this guy over here, and then run this guy over to here. Okay. Actually, it's going this way, and then. Okay, I gotta put my switch in the other way. There we go. So then go that way, and then I can push the switch, and the light doesn't light. There you go. Get it in the right hole. That's half the battle, is getting all your things in the right holes. So then I push that switch, and that lights up your light. Okay, and the connections are not always great with these flexible ones. With these solid ones, the connections are usually better, so you might have some flicker here. Plus, when you're using a brick, you'll have more solid voltage. With these batteries, they have a circuit in them that tries to detect whether it's got a load on it, and so it takes a moment or two for it to fire up. So we've got our push button right here. Let me just move this over here one so that it's kind of right there. We'll put that guy right there and right there. So that switch, push that switch, and your light lights. Pretty simple, very simple circuit. But we have our resistance through there so that we've cut down our voltage from 5 to about 3, what the LED's asking for. So then, what if I want to add my blue light to it, I'll just jump from here to 15, from 10 to 15 on this side, and then from 10 to 15 on this side, and that runs these two in parallel, not in series but in parallel, and now we got a blue light and a red light both lighting up with a push button. Very simple. So that's the first project, is just a simple push button switching circuit that brings on two lights in parallel. And if you go to the USB drive and open up some of those documents, you can find projects, breadboard projects, that are anywhere from real simple like this to really, really complicated, that use some of these integrated circuit chips and can do all kind of remarkable things, including run a robot. And so this is kind of an introduction to the world of electronics. And I think I may leave this together just so that you can see it. I'll leave it together when we put the whole package together for you. And but take a look at those other documents that I've got on the USB drive, and you can look on YouTube or just search the internet for simple electronic breadboard projects. Just say, breadboard projects, and they'll come up with all kind of things that you can build with a breadboard, including robotic circuitry. So that may help you have an edge when it comes to robotics, particularly the further you get on into it, because it gets really exciting as time goes on. So that's all I got for you today. Thanks. Bye.